Hello everyone, I am Akshata Wadgaonkar, working as an assistant professor at Walchand Institute of Technology, Solapur. Today I am going to conduct a lecture on convolution integral. These are the learning outcome. At the end of this session, student will be able to learn step used to perform convolution integral. These are the content. I am going to discuss about introduction to convolution, step used to perform convolution integral, and then I am going to take one example based on this convolution integral. Now let us discuss about introduction to convolution. Convolution is a mathematical operation used to combine two signals to produce the third signal, such as y of t which is equal to x of t in multiplication with h of t. Convolution is widely used in signal processing to determine the output of system given its input and impulse response. The mathematical formula used to calculate convolution integral is y of t which is equal to integration of minus infinity to plus infinity x of tau h of t minus tau into d tau, or we can write down y of t which is equal to integration of minus infinity to plus infinity x of t minus tau into h of tau d tau. Now let us define the first step which is used to perform convolution integral is that we have to define the function. Here the convolution process involves the two signal x of tau which is nothing but input signal or excitation signal. Second one is h of tau which is nothing but system impulse response, which is used to show the performance of system, how it react with an given input signal. Before performing the convolution, we must define the two functions that will interact. Step number 2 is fold or reverse the impulse response. We have to reflect the h of tau across the tau axis to get h of minus tau. This flip the impulse response function in time axis. This time reversal is essential because convolution calculate how much overlap exists between two functions as they slide past each other. Now let us discuss about step number 3, which is nothing but shift the folded function. Here we have to fold the function h of minus tau by t to get h of t minus tau. This shifting allows us to move h of minus tau along x of tau axis, the testing how much overlap there is at every point. The value of t will determine how far the impulse response is moved. Step number 4 is determine the range of integration, or we can find out here the limits of integration to perform the convolution. Now we identify the range of integration, the region where x of tau and h of t minus tau overlap. This set the limit of integration by identifying the range where both the signal overlap. Convolution only happen where both signal have non-zero value, so it's important to define the exact range before performing the next step. Now let us define step number 5, which is nothing but integrate. Here we have to compute the convolution integral by using formula y of t which is equal to integration of minus infinity to plus infinity h of t minus tau x of tau d tau. Here once we have overlapping range, we can calculate the convolution integral. Step number 6 is that we have to repeat the all values for given t. Here we have to compute the y of t at different time value to get the complete output. The result is new function representing the converged signal, and at last we can sketch the resulting output if needed to visualize how the convolution affect the signal. These are the steps used to perform convolution integral. Now let us take one example so you can easily understand how we can compute the convolution integral of a given signal. The example of x of t and h of t is given, and we have to find out its convolution integral by using the method that we have seen just. So see, x of t is given and h of t is given. So our step number first is we have to convert, or we have to just replace t by tau. Okay, so we just have to replace t by tau. So we can plot the graph of x of tau and h of tau. So x of tau is what? Which is nothing but 0 to 2 with a tau axis, and its amplitude is 1. Okay, so just what happened, we are just changing the variable t as tau, and then this is the graph of our x of tau, and then we have to plot the same for our impulse response, that is h of tau, which amplitude is 0 to 1 with a tau axis, which is nothing but the graph of our h of tau. So here we plot the graph of x of tau and h of tau, which is nothing but our first step. Just we have to replace t by tau. Now step number 2 is we have to flip the h of tau, okay, and we have to plot h of minus tau signal. So how we can plot it? Just we have to perform flip operation. So this plus 1 is minus 1 in flip and amplitude is same. We are not changing here amplitude, and this is the graph of our h of minus tau, okay, and the axis is tau axis. Now step number 3 is we have perform shifting operation. We have to perform shifting operation in step number 3, that is we have to plot the graph of h of t minus tau. So we have to perform the shifting operation on this h of minus tau to the t. So it is shifted toward the left hand side and started from t to t minus 1, and amplitude is again same, amplitude is 1, okay, and this is the plot of our h of t minus tau, okay. Now step number 4. So in step number 4 we have to check the different condition of t to find out the overlapping region. So first of all we check the conditions of t. We have to check the conditions of t to find out the overlapping region. So first step, when t is less than 0, what happened to our h of tau and x of tau, that we have to see. So see, when t is less than 0, x of tau is as it is. It is in between 0, 1, 2. But what happened to h of tau here? X of tau is same. Now see, what happened to h of tau? H of tau is what? T is less than 0. So that means it is here, okay, that is t and t minus 1. So no overlapping is present here. So if there is no overlapping, then y of t is 0 in this case, okay. So y of t is 0. Now check the different condition when t is greater than 0 and t is less than 1. Now what happened? Again our x of t plot is as it is, 0 to 2. This is the plot of our x of tau, okay. Now we have to plot h of tau, which is nothing but t is greater than 0 now but less than 1. That means it is started from here. So amplitude is same, okay. Amplitude is what? 1 here, but here we are getting the overlapping region, and this is our overlapping region. From here it is what? T, and here it is t minus 1. So overlapping region is from 0 to t. So here we have to find out the convolution integral from 0 to t, and then what is the amplitude here? Amplitude is 1 into d2. So what is our integration here? 0 to t, then t, okay, or we can directly write down dt. So it is tau in bracket 0 to t. So what is the value of our convolution integral here? It is nothing but t, because t minus 0 is t. This is our next value of y of t. Now we have to check for next condition when t is greater than 1 and when t is less than 2. For this condition we have to check the value of our convolution integral. So before that we have to check the overlapping region. Again our x of tau is as it is, in between 0 to 2, 1, here it is 1. This is the plot of our x of tau. Now we have to plot the graph of h of tau, which is when t is greater than 1 and when t is less than 2. So that means it is start from here and it is up to this. So we are getting this region as our overlapping region here. And what is the amplitude? Amplitude is same, t, and here it is what? Time t, here it is t minus 1. Now our overlapping region is from what? T minus 1 to t. So we have to take the integration from t minus 1 to t. Again amplitude is same, into d2. So how we can write down? I can write here as t minus 1 to t, okay. So now what is our integration value here? T minus 1. So what is output? Y of t is equal to here plus t minus t get cancelled, plus and this minus minus become plus. So output is plus 1 here when t is greater than 1 and less than 2. Now check for the next condition. So next condition is what? When t is greater than 2 and t is less than 3. So see what happened in this condition. So in this condition again we have to plot the graph of x of t as it is in between 0 to 2. This is the plot of our x of tau on tau axis, and we have to plot now h of tau. Now t is greater than 2 but it is less than 3. So suppose 3 is there, that means our graph greater than 2 is started here, but it is less than 3. So here it is what? T, and here it is t minus 1. So overlapping region is this one between x of tau and h of tau. Now y of t is equal to what? Integration of t minus 1 to 2 1 into d2. Okay, so how I can write down here? So I can write down here as tau to t minus 1 to 2. So what is the value of integration? Y of t is equal to 2 minus t minus 1. So I can write down, so y of t equal to 2 minus t minus 1. So what happened here? It is equal to 2 minus this minus t minus minus plus 1. So it is 3 minus t. Y of t equal to 3 minus t. This is our next value. Now we have to check different value when t is greater than 3. So again we have to plot the graph of x of t as it is. It is from 0 to 2 1, amplitude is same. This is the graph of our x of tau along tau axis. And now what happened? T is greater than 3. Greater than 3 means it is started from here h of tau, okay, and up to this. So it is what? T, and here it is t minus 1. So again we are not getting any overlapping region. So y of t what here? So y of t which is equal to 0 again. Okay, so what values of y of t we are getting here? We are getting the values of y of t as y of t which is equal to 0, which is equal to t for t is greater than 0 and t is less than 1. Next value is 1 when t is greater than 1 and when t is less than 2. Next value we are getting, it is 3 minus t when t is greater than 2 and t is less than 3. Next value is again 0 when t is greater than 3. So this is the value that we are getting the convolution output. Now what? We can plot the sketch or a graph of this also, our convolved signal. So what is the value? 0 1 2 3, amplitude is what? 1 2. Now see, when it is less than 0, what is our amplitude? Again 0. When it is between 0 to 1, amplitude is what? T. So in between 0 to 1, amplitude is t. So now substitute the values between 0 to 1 and we can calculate this value of t. When t is 0, again 0, 0.5 means somewhat here. When it is 1, then it is like this. Okay, 0 to 1, 1. In between 1 to 2, we are getting constant amplitude as 1. In between 1 and 2, amplitude is constant 1. In between 2 and 3, amplitude is what? 3 minus t. In between 2 and 3, amplitude is 3 minus t. So see, when we substitute t as 2, so it is 3 minus 2, it is 1. Okay, when we substitute 3 as 3, so 3 minus 3 it is again 0. So this is our final output of y of t of convolved signal of. These are the references that I have taken. So I hope now everyone is understand how we can perform the convolution integral of given continuous time signal, and we have seen the steps used to perform convolution integral. So thank you so much.